Hello, everybody, and welcome to episode number 57, in which we will continue in Life of a Packet. So I'm really looking forward to this episode, and for this episode, I will be joined by my good friend Nicholas Lane. He's somebody I've worked with at a couple of previous companies, and just always a pleasure to hang around with you.
Hey, man, thanks for having me. And likewise, it's always a pleasure to hang around with you and talk tech or pretty much anything.
Exactly. Nick and I share a coast, but there are quite a few miles between us, unfortunately. But it's always
it would be fun to do this live though if I could ever get down to the Bay Area.
Yeah, I probably have more reason to go up to Seattle than you have to get to the Bay Area. But like one way or the other, it would be a blast. I agree. So the news of the week, as always, our notes are online. If you go to hackmd.io/echo live, you're going to see episode 50. You're going to see this published as number 57, and that's where the notes are. I'll also just go ahead and put a link into the chat so that you don't have to go looking for it. Comments, bam. And there is Russell saying hello. How you doing, Russell? Good to see you. And if you're in the audience, if you're interested in this kind of stuff or interested in more of this kind of stuff, just let me know. I always like doing these episodes, but I kind of wonder sometimes if people are actually like getting anything out of them. Tricky stuff. So eBPF Summit registration is now open, or it has been open for some time. It's going to actually be a pretty fun summit. It's going to be an all virtual summit, so there's no in-person piece to it, except for the fact that I'm actually going to be flying back to Zurich to help host it, and that'll be a trip. The previous summit, we actually hired an external company to handle a lot of the interactions with like the interstitials and everything between different talks. And this year we've decided just to kind of host it in-house. So I'll be brushing up my OBS skills and showing off some cool stuff at the eBPF Summit. So if you want to come be a part of it, definitely check it out. Another thing that I was actually super excited. I mean, I've known about this program for some time, and the program is pretty solid itself. The program is a scholarship which actually helps pay for people's travel and their stay at CNCF events. And so it's really pretty great because it is need-based. It's not just students. It's like everybody who wants to get involved with the community but can't afford to do that on their own because it is somewhat expensive. They really are focused on trying to bring in diverse applicants into this program. So if this actually sounds like something that you would like to be a part of, definitely check it out. But one of the things I was really excited about was seeing the Isovalent logo there underneath the scholarship sponsors. And so really awesome that we're supporting that.
Yeah, I'm very psyched about this as well. I think this is one of the best things in the CNCF community,
Yeah.
Helping out people. Because you mentioned it's expensive to go to, KubeCon and things like that. It's like prohibitively expensive. So the scholarship enables people who wouldn't have a chance to go, get to have the experience and also, a bit of the what is it called? The sidewalk track, the
hallway track. Yeah.
Hallway track, that's it. Where they wouldn't, get exposure to people that, they never would have before. So, and it's awesome. And I'm very, very happy to see the best logo at the bottom.
Yeah,
I might be a little bit biased though.
Super jazzed. I was very happy to see that. Hello to Sadiq, who is calling in from Oman, Dubai. Good to see you. Next up in the news, one of the tweets I guess it was a little while ago. I thought it was an interesting one from Chris Anasesic. Talking about working on an updated cloud-native FDN project velocity report. Top 5 projects in terms of velocity are Kubernetes, Hotel, Argo, Backstage, and Prometheus. What's fun about this logo is that we're on it way out here. Cilium rising. It's like pretty awesome that like we're kind of like just way ahead in I guess it's the logarithmic commits, but super exciting to see to see Cilium show up there. It's pretty awesome.
Yeah.
The cube. Go ahead.
Oh, so yeah, that is really cool. Though I need to read into this a little bit more and figure out exactly what logarithmic commits mean. I think he leaks to something that
talks about it, but I can't remember exactly what it means myself. The KubeCon North America schedule is online. We have lots and lots of talks, and I'm probably going to do an episode, probably with Nick, prior to the show, doing a warm up of talking about the talks we're going to talk about in the talking, and then that'll happen. Like, as we get closer to the event. But there's also going to be some great talks. There's also going to be an eBPF summit. There's also going to be an eBPF day prior to the show, a day zero event as usual. But there's going to be lots and lots of really great stuff. I managed to get a talk into KubeCon this year, and I also managed to get a talk into KubeCon that has nothing to do with eBPF, except for in kind of a meta way, right? So the talk I got in actually involves these things, which is a Rubik's Cube, and I think I've shown you this on these shows before. But my talk is actually about perspective, and I'm really looking forward to giving it. It's a talk about, like, learning something technical, and as you like move through the layers of your own technical ability, right? As you like get better and better and more knowledgeable around particular things, it is almost a foregone conclusion that you're going to lose sight of the perspective that you had when you started. And like, this exercise is really, and this talk is really an exercise in how can we like use that perspective to understand that we don't see how others are experiencing what we experience, because they can't, right? Like, so it's a puzzling solution. I think it'll be fun. I'm looking forward to that talk. We have some comments from, I'm not going to try it. I don't want to mess your name up.
Dara.
I'm pretty sure it's Dara. Yeah. Great to see the sessions going on Friday evenings. Yep. Great to see you from Switzerland and Ireland. Okay. That makes sense. I think that's an Irish name. Dara, is that an Irish name? And you're just living in Switzerland. By the way, KubeCon is also expensive. Yeah, it is. Getting more value from KubeCon is what needs to improve to justify the cost. Look at the MWC prices, and you'll see it's not too far off the top conference prices. Yeah, I agree. And there's actually been some recent discussions within the CNCF about kind of a related topic, which is that when you get a talk into a day zero event, a part of getting that day zero talk in is that you have to pay for a registration for the regular event. So say you got to talk into eBPF Summit, into the eBPF Day, or to the Security Day, or one of those talks. You're actually required to have a registration to KubeCon to go and deliver that talk.
Which seems a bit odd, right? If you're only going for, let's say, like telemetry days or eBPF days, and you're not actually planning on going to KubeCon, that's a huge cost to just go to this one summit, right? So I totally dig it.
So I was excited to see that conversation is being had, and I think there's definitely stuff that the CNCF can do there to improve things. But
yeah. And to Dara's point, there does need to be a return on investment for individual people going. Like, if I wasn't relying on my company to help me go to KubeCon, I don't know if I would have gone to nearly as many KubeCons as I had, or actually, I know I wouldn't have, because I think that there is a lot of value in KubeCon for sure, and I do think that there's enough value to justify paying for it out of pocket, but it really, I think that KubeCon can improve quite a bit to justify that cost for the individual payers for sure.
Yeah. I mean, on that note, one of the things that I found exciting during this whole pandemic period was actually the effort around bringing a virtual KubeCon experience, and for a couple of reasons, right? Like, both are pretty related to this conversation. One reason I think that virtual KubeCon is actually good is because it actually lowers the barrier of entry. You don't have to fly there and be there in person. And a lot of the community members, like, Dims, myself, Priyanka, a bunch of people were actually really involved in ensuring that there was also a hallway track in that experience, so you could actually meet and spend time with people, even if you weren't there in person. And so I think that, having the virtual cons it's also a helper there, because it's also greatly reduced in price. I remember the virtual con was something ridiculously low, like $80 or something, and then the major con, showing up in person was much more expensive because of the liability and everything else.
Sure.
But yeah, interesting stuff. I'm hoping, I do hope that we continue to improve and that things get better in the way they things work. So we have the next episode of eBPF newsletter out. And the URL is isogo2 echo-news-12. Inside of here, there's lots of really great weekly content. And if you want to subscribe to it, you can just go to isovalent.com and subscribe there. This is hosted and curated by Bill Mulligan, so pretty awesome. One of the first ones that Bill calls out, the technical peeking into the BPF verifier. It's kind of like chat roulette. So one of the questions that Russell asks is how do they do the virtual hallway track? And so what we have done in the past is that in the CNCF Slack for the event there would be a hallway track channel, and inside of there somebody will host a Zoom session or something like it, and then what we were doing, there was also a couple of events on the actual conference schedule that were kind of meet and greet kind of things, right? And so you go into the Zoom session, you could just come and go into the Zoom session and hang out with people that were there, kind of the way that you would see people in the hallway. And then at the scheduled times, you could come in and we would separate everybody up into like the smaller breakout rooms, and you would get to introduce yourself and chat with people and meet people you haven't met. And we would make sure to attract lots of people into that situation so that you could meet people that maybe you wanted to meet or that you hadn't had a chance to meet yet. And that was really fun. I ended up doing this, and I think there were maybe it was a pretty good number. It was 100 something, 200 something people in the big Zoom. And when we broke it out, I ended up in the same breakout room with one person twice, him and two other people. And I thought that was kind of funny, kind of random. But yeah, that's how they do it. And it worked out pretty well. Key metrics for monitoring Cilium. We're working on this piece of it. So Datadog actually just put out a great article on monitoring Cilium. This is one of the first in the wild Tetragon talks. I ported my command line cloaking test to NIM and used it to explore Tetragon, the latest eBPF security observability tool. Oh, nice. Actually talking through how do you actually hide? Oh, that's cool. Hide an application.
Yeah, this is a really interesting article. I highly recommend going through it. There's just a lot of good data in here, and a lot of it goes very, very deep too. There's some stuff where I'm just like, what are we talking about?
Yeah.
So
yeah, that's cool. This will be a fun one to kind of play with. Actually, I think I might do an episode like this before at some point.
Yeah, absolutely. And I love seeing things like this that go step by step and really give you the guidelines to do some of this testing yourself. So I think this is a very well written and very interesting article for sure.
Yeah, that is pretty fun. Yeah, trippy one. All right, good stuff in there. Also some pinpoint service mesh critical performance impact by using eBPF, written by the Apache Skywalking Rover stuff. And then what else we got? Intro to eBPF, written by Chris Short just recently. I thought that was a good article. And then also this one looks pretty good. It's Datadog acquires Secret, and Secret is a tool for using eBPF to monitor API interactions and that sort of stuff. So I thought that would be kind of an interesting name, but
I can't not read it as secret, even though I know it says secret. For some reason, my brain doesn't make it say secret. It says secret, and it changes the context a little bit.
Yeah, but tons and tons. I mean, there's so much here. I'm not going to go through all of it. But there was actually one more thing I did want to talk about, which is that we've just updated the labs. If you go to isovalent.com, you go to resources. And inside here, you can do a hands-on lab. These labs have actually just been bumped to the recent version of Cilium. So if you're interested in like getting hands-on with Cilium, this is a great place to jump in and check these things out. All right, let's get into the episode. So today I'm actually going to keep going with this series, which is our life of a packet. In the most recent episode, the most recent Life of a Packet episode, I was taking us through kubeproxy and showing how Cilium interacts with kubeproxy when kubeproxy and Cilium are both deployed together. And basically what we learned from that episode was that like Cilium with kubeproxy will continue to manage cluster IP services regardless of whether they are whether Cilium is doing kubeproxy replacement mode or not. So that means that when your application tries to make access to a cluster IP from inside or from an endpoint known to Cilium, when it tries to make access to a cluster IP, there will be a part of the eBPF program associated with that endpoint that will make the decision about where to send that traffic. And it'll make that decision before IP table sees it, right? So that when the packet shows up in the host network namespace, that decision has already been made, and it just looks like pod-to-pod traffic at that point. It's not actually triggering the IP table's rule set that is related to determining where to send that traffic, because the decision has already been made and the packet has already been changed. It's already gone through NAT by way of Cilium. That's what we learned in this most recent episode, in episode 53. And if you want to check it out, I think I have a link to it right here. That might be a previous kubeproxy episode, but if you look at episode 53, you're going to be able to see all of that. And we really went into some great detail there. I think it's definitely worth checking out. In episode 55, I actually did a release episode, which was really awesome. It was a Cilium 1.12 release episode in which we had a bunch of developers, external developers and internal developers of the Cilium codebase come in and talk about the different features that they helped bring to Cilium in this 1.12 release. And I thought it was great. It was really pretty neat, and it was also really kind of neat to see kind of like what their experience was like, and how all of that went for them, so that we can use that information to kind of improve the way that we're managing things, and also just to see I think we're doing a pretty good job of like keeping it, keeping people feeling supported when trying to contribute code to something as complex or possibly as intimidating as something like Cilium, right? I mean, a lot of people will come to the Cilium project and go, I don't know eBPF, I can't possibly contribute, right? And that's just not true, right? Like, we need docs like everybody else. We need people who are writing just Go. We need people who understand IP tables. We need people in a variety of different areas, and we also have, good first issue labels and all that stuff in place. And so again, if you want to help contribute to Cilium, it's very approachable, and we have just an incredible base of folks that are there to help you, get you unstuck, keep you moving in the right direction, chat about what you want to do, all that good stuff. Come check it out. Now, in this episode, we're going to play with a kubeproxy replacement, which will be a very different thing, but let's get going on that. Hopefully I don't just crash my Zoom again, or crash my my thing again. That was kind of wacky. All right, clear. Here, 57.
So Duffy, what exactly are we going through all today? So it's life of the packet without kubeproxy replacement. Like, what's kind of the overarching agenda for this demonstration?
So for this demonstration, what we're going to do is we're going to create a Kubernetes cluster that has kubeproxy replacement mode in place, and we're also going to walk through how we go about creating a cluster without kubeproxy. We're going to show that kubeproxy is not in place. Then we're going to deploy Cilium in a way that it can replace kubeproxy. And then we're going to look at how Cilium sees the world once we actually have, once it's doing the kubeproxy replacement stuff. And then we're going to go through and kind of show the difference between what that looks like with kubeproxy and without, and all of that stuff. And there is a flag that I actually helped figure out in. So I'm going to be using kind for this configuration, and kind has this. Kind is leveraging kubeadm, which is an open source project that actually helps you stand up and create Kubernetes clusters. Kind, for the most part, is really focused on taking you from the place where you have like a bunch of servers and you want to turn them into a Kubernetes cluster. kubeadm is focused on that. Kind is actually focused on doing exactly that thing, but instead of servers, you have Docker containers. And so if all you're doing is testing the code path of things, then frequently kind is a perfect tool for actually digging into like whether particular code paths work. The other thing that is neat about that is that kind is actually leveraged in CI for Kubernetes to do exactly that. So if you make a commit change, if you make a change to, I don't know, the way the kubeproxy implements IP tables rules, right? You found a bug, you fixed it. Before you can actually commit that will go through a CI test leveraging kind to validate the IP tables rule set that you have applied. And it will also, what else? So it will also enable you to build a kind cluster from your local checkout of the Kubernetes code base, right? So in this way, you can actually, you can actually work through end to end on your commit, write tests, run them. Like you can do all of that stuff like against your local checkout of the Kubernetes code base, so that you can build confidence that the thing you actually changed is actually the thing you changed, and that all of the other tests aren't broken now. And like you have everything you need with kind to be able to kind of determine that for the most part, everything you need is there to be able to determine that you haven't broken the world, which is pretty cool.
Yeah. If you haven't taken a look at the testing suite for Kubernetes and the use of kind in it, it's really, really sophisticated. It's awesome stuff. And also, kind is like my favorite way to stand up a Kubernetes cluster, just for testing purposes. Obviously, it's not for production use. I'm actually curious, in chat, how many people are using kind on a regular basis, either for prototyping stuff or just to like run examples of things like that. So give us like a +1 if you're using kind. I'd be curious to see how many people are using it.
And I agree with you, Dara. We need people to understand we're moving away from IP tables. That's also true.
Yeah. Yes, IP tables is great, but it wasn't designed for a cloud native workload like Kubernetes. This thing that's a massive firewall that needs to make thousands of changes every like minute or so. Maybe not the design scope it was going for.
Exactly. All right, so let's talk through this configuration here real quick. First, I'm going to kind of turn off this border so that you can see it. There we go. So this is my kind configuration. I'm going to be creating a cluster. And there I've got a couple of different settings here in the networking chunk of the configuration. I have disabled default CNI. By default, kind will create a cluster that uses kindnet, which is a CNI developed just specifically for kind. And this will actually disable that, so there will be no CNI when the cluster stands up. And then also we have enabled the feature to allow for us to disable kubeproxy. Now this is, if you're going to do this with kubeadm, right, then basically if it's kubeproxy none, what we're doing is we're skipping the phase of kubeproxy. So in kubeadm, there are multiple phases. As it brings up your cluster, one of those phases is the installation of kubeproxy as a daemon set. And in this setting right here, I'm basically telling kubeadm to skip that. And so when I create this cluster, it will be one control plane node, 2 worker nodes, and no kubeproxy and no CNI. All right, create cluster.
So while you're doing that, a LinkedIn user asked, can we get a recording of the session? This session is recorded.
Yes, you're watching the live recording.
Yes. So everything you type will be recorded. But also, yeah, this will be available right after the session ends. It'll be available on YouTube at the same link, I believe.
Yep, it will be. The reason you are asking the question might be, I always forget to do this, so I'm just going to do this now, so I don't forget to do it later. which is that in YouTube, I can actually tell it to put this as part of the playlist.
Mm.
And then I'll also just put the playlist in. Your videos.
It'd be very fun if someone was watching the playlist, happened to get to the last episode, and then the live recording started playing right in the middle of it.
Right? Save. Okay, now it's part of the playlist. And the playlist is all right. So back to StreamYard. Here is the playlist. That's the eBPF, that's the eCHO Office Hours playlist, in which you can see all of the previous episodes. So definitely check it out. All right, our kind cluster is up. Let's go ahead and take a look at what it looks like.
One thing I always love about kind is the use of the emojis in the status for the installation. It's just something, it's very minor, but I really enjoy it.
Yeah, I agree with you. So we can see that we have a basic KubeADM cluster set up here, right? We have our API server, and we can see that these are static pods. That's why you see this kind control plane on the back end. When you see something named when you see a pod that's been defined and you see a node name just hyphenated after it, like that means it's a static pod. That means it's running as it's being owned and operated only by the kubelet. Interestingly enough, if I delete that pod, let's go ahead and do that. You're going to love this. I always love this trick. Delete pod -n kube system. Now, if I do this, right, then the kube API server should be gone, right? It should be gone. Okay, pod -n. And it is. Well, it's not yet gone, but it's pending. Right. So I deleted it, but it's still there. I'm still talking to it.
But Duffy, how did you do it?
And the reason that happens, now it says it's 10 seconds old, but the API server never went down for me. Like the whole time it was still just like present. So the reason that happens is because when you delete a record, when you delete a pod like a static pod, it doesn't actually get deleted. What you're doing is deleting the record of that pod. The pod itself is still managed by the kubelet, and it will continue to run in perpetuity. It never goes away. It's just sitting there. It's entirely managed by the kubelet. It doesn't actually get deleted when you delete it. So I thought that was kind of interesting stuff. All right. The first thing we're going to do, we're going to go ahead and install Cilium. So for that, I'll make sure I have, yeah, cool. Cilium install, helm set. Please. Yes. Let's try this. Cilium install. Helm set. This is a new feature in the Cilium CLI where you can actually pass arguments like you would to Helm, and Cilium will template Helm based on the configuration that you've given it and pass those values in, which is pretty slick.
Yeah, I think it's really neat. I haven't actually had a chance to play with that feature yet, so this is fun for me too.
So that's the Helm set piece, and it can take an array, right? So if I pass multiple values, I just need to do key equals value and then a comma between the arguments. So Cilium install dash helm set K8 service host. K8 service host kind control plane. Now this is actually a little bit wacky, and we're going to talk about what's happening here in just a second, but service port, oops, 6443. Then we want to enable kube proxy replacement strict. Okay, let's talk about what's happening here. So We're going to replace kubeproxy. There's a couple of interesting things about kubeproxy. Kubeproxy actually needs to know how to interact with the API server without kubeproxy. So inside of a Kubernetes cluster, there's this default service that's been defined inside of, are you following the SIM? Yeah. I am following the install document. So when you replace, so kubeproxy, when it is added to a Kubernetes cluster, it's actually going to get a credential that allows it to authenticate to the API server directly. It's not because it can't rely on a service abstraction to interact with the API server. So for example, most things inside of your Kubernetes cluster, core DNS, other things that are actually going to interact with the Kubernetes API server, right? They're going to interact with that Kubernetes API server by leveraging the Kubernetes default.service that has been defined as part of the cluster bring up. But that is a service, just like any other service. It's just a really early one. And that service is implemented by kubeproxy. So you can see the challenge, right? It's a circular dependency. That means that kubeproxy, when it first comes up, it can't rely on the service to talk to the API server because it hasn't created it yet. So instead, it actually has to have a credential and an endpoint to go and talk to the API server that is external to the cluster. This is true of Cilium when it replaces kubeproxy as well, right? So for Cilium to know, how to go look up those services so that it can implement them, it needs to be able to talk to the API server in a way that doesn't rely on the Kubernetes service to accomplish it. Otherwise, it will not work. Interesting stuff. The way that we solve that problem is that we leverage this mechanism here. We are actually allowing you to define what the service host, that's the host name or the IP address of that API server, the service port, usually 6443 in Kubedium setups. And these two values are very much necessary if you want to run in KPR or kubeproxy replacement mode. If you don't set these two values, then Cilium won't start up because it can't establish a connection with the API server.
Ask me how many times I've been bit by that.
Yeah.
More than I'd like to admit.
Yeah. So, and interestingly enough, we're going to talk about the way this is implemented because I think this is actually pretty neat, but we're going to talk about the way it's implemented here in a second. So let's go ahead and get this started. Now, a part of the Cilium output here is it will actually tell us what the install command is that it's doing, right? So what it's going to do is it's going to do a Helm template in the kubesystem namespace of Cilium against the Cilium repo, passing version 1.12.0. It's going to give it a cluster ID. The cluster name is kind. It's not enabling encryption. The IPAN mode is going to be Kubernetes, and the K8 service host, that's where we're setting those values that we just set. Operator replica is 1 because it's a kind cluster. Service accounts are being created, and then we're going to use the VXLAN tunneling mode. Now, if I do Cilium status, you can see that things are just kind of finishing coming up here. Oh, I shift on the brain, sorry. There we go. So clusters are coming up. Waiting for the Cilium pods to go 1-1. There goes one of them. There goes two of them. There goes three of them. Our core DNS pods should come along. There we go. All right, what else? I'll make my laptop faster. And when it was proposed, up to 15 seconds. All right, there we go.
Yes, also
now our cluster.
Dream a little dream. Do not feel stupid. This is never feel stupid about anything, particularly jumping into a live stream halfway through and trying to figure out the context. Absolutely not.
Yeah. Oh, wow. That's funny. All right. Yeah, don't feel stupid. This is complex stuff. So we have our cluster stood up. We have our Cilium agents running on each node. We have the operator up and running. Core DNS is propagated. All of the things are running, but we can still see that we don't have a kube proxy, and all of that stuff is not in place. Now, the next thing I wanted to show you was the way that KH service stuff is implemented, because I find this to be pretty neat. Edit ds-n kube system. So inside of this daemon set is actually how we get Cilium deployed inside your cluster, right? And there are a couple of different things that we get passed in, including these values right here. Now, what you may not realize is that these values are values that exist automatically when you create a pod. And what we're doing by setting the environment variables of Kubernetes service host and Kubernetes service port, we're overriding those default variables to use this new setup instead. Let me show you what I mean. If I do kubectl run, I just create like a little bash container real quick. And this is just a standard overlaying network pod. Then I can see that in my environment, I have Kubernetes service port and Kubernetes service host defined, right? And that's actually defined as part of the Kubernetes default service, and every pod will get it. Every pod gets this information. It doesn't matter whether you want it to be there or not, it will always get it. I think that there is a value in the kubelet where you can actually turn this off if you don't want it to be present, but generally speaking, it'll be there.
Is this part of the downward API? Because I know the pod IP address and all that gets injected by the downward API.
It can be, but in this particular case, it's actually part of the built-in for every pod's environment.
Okay, that was a little tidbit that I wasn't aware of.
Yeah, it leverages the same mechanism as the downward API. So if you actually did want to set another variable that includes like the node name that you're a part of, then you can actually set that, and you can set that, and it leverages the same mechanism. The difference is that in this case, this is just how all pods are created, so that they can rely on the internal representation of that API server. Kubectl get svc Kubernetes YAML. So this is the 1096.0.1. That's the first IP address in your service side or range, and that first IP address is actually the Kubernetes default service. And so by default, that's actually what gets put in there. And what we're doing is we're overriding that with our own configuration. We're overriding that with the host name of the host that is running the API server and the external port used to interact with it, so that we can stand up kubeproxy. Now, a couple other things we want to do here real quick. Let's see, 55. Where did I put it? One second here. What I want to do is I want to go ahead and create that that per node thing that we ran last time, and we'll talk through that real quick. Let's talk about what this is. So this is a pod that will create one pod per node. Actually, create 2 pods per node, and it will name them net, and then the iteration 1 or 2, and then the name of the node, so that I can understand like which node these pods are associated with, and it will also create a service associated with it, and that service will be of type cluster IP. And then we'll just go ahead and interact with that and prove that kubeproxy works. So let's go ahead and run this.
You mean not kubeproxy?
I do mean that the functionality of kubeproxy is actually doing the thing it's supposed to do. Because although there is no kubeproxy in the cluster, there is a replacement for it. And so I want to prove that that replacement is actually doing the thing it says on the tin.
Right.
Wait for these guys to come up here.
One of the things I always love doing these streams is seeing how different people organize what flags go where in a kubectl command.
Oh man, I am definitely lawful chaos. Like,
I was watching it, I'm like, what the hell? There's no rhyme or reason to this.
no, like, not at all. Yeah, like,
yeah.
I'm actually one of those that actually remembers. I only know, like, there are a lot of flags that I know have to come before particular, elements, and so that's like literally the only rule I follow is that it has to have. like if you're gonna do a Docker run and you're gonna pass a volume, it has to come before the image name. Right?
Yes. Yeah.
I know that explicitly because I've tried doing that other thing lots of times and it doesn't work out.
Yeah, for me, it always has to go kubectl, namespace, and then whatever I'm doing. Unless I'm doing something against the whole cluster, then it doesn't matter. Like I can't not do it. I have to organize it by namespace in my head.
Oh, ka-chunk. What happened there? Oh, there we go. All right. So now we have our cluster. We have our pods set up, and this is basically that net service that I was talking about. So now I have, I've created something that looks very like static pods, but in this case, it's actually independently defined pods that are running inside the cluster, right? And so here is my net1 kind control plane, net2 kind control plane, and then I have one for each of the worker and worker 2 of the kind cluster. And we can see that, in reality, these are actually what they say they are. They're running on the nodes where they're supposed to run. And if I do kubectl get svc, there is a service called net. And then, I'm actually going to go ahead and recycle that pod real quick. This. Well, I don't know if this will work. Dash. All right, kubectl delete. I want to show you something else real quick. And then, always real quick. I'm just going to wipe out that pod. I don't want to restart it. Go away, pod.
Is it just me, or does it seem like it takes pods to terminate way longer than it used to?
It's a problem that kind of comes and goes,
I just feel like, back in like the 1.5 days, like whenever you terminated a pod, it was just like done.
That was quick. That was before finalizers.
That's fair. That's very fair. That was the Wild West days.
Okay. I've already interacted with the service, but we're going to talk about that here in a second. So I wanted to restart this thing because I think this is also pretty interesting. So now we are inside of a pod that has been a new pod that was created after I created that net service. And by kubectl replacement, I mean Cilium. Yes, I mean that there is a way that you can deploy Cilium that can replace kubeproxy, and Cilium can be the replacement of kubeproxy. We're going to get into it here in a little bit more detail. Just stay with us, and you'll be able to see how that works. So one of the other things that happens that Kubernetes does by default is that it will actually create a link to services if they're brought up in order, right? So in my case, I had to restart my bash process because it started before the service was created. But now that service has been created, I actually have information in my environment variables that describe that service. If I do a curl against that service, and I can actually see that, and I just do it a couple times, I'll be able to see that I'm actually talking to multiple endpoints behind that service. Okay. So this is actually interacting with different services in that, with different pods within that service. Now, what's neat about that is that means that kubeproxy is working even though there is no kubeproxy. Now, last time in the most recent episode, what I did was I actually showed you how kubeproxy is implemented in IP tables. Docker exec-ti. See, I do IT, TI to mix it up. Keep it real. I don't like to get complacent.
Yeah, I see. That's how you keep it fresh.
Right.
Even you don't know what you're going to do next.
Ah.
Right.
So here we have the IP table save of a Cilium cluster running in kubeproxy replacement mode. And you'll notice that there's not a lot of rules, right? I mean, like, what is this like? This is probably 98 rules total. And there aren't
not a lot of rules.
Yeah. And there aren't any kubeproxy rules. There's no kubeproxy table. None of that stuff is present. And that's because kubeproxy is not doing this job, but somehow it's still getting done, right? So let's take a look at how it's being done. So I'm going to actually, I wanted to do a wide there. I'm going to jump into this guy here on the kind worker node. Oh. Okay, so now I'm inside of that agent. And now last time in the previous episode, we went into some detail around like how Cilium Monitor works, how Hubble Observe works, how all of those things work inside of this particular, from the perspective of this agent or from an agent running like this. But one of the things I wanted to show you real quick was a little bit of a difference in what we saw last time. If we do Cilium status verbose, we can see that this chunk of configuration is pretty different than it was last time. And I guess, it probably would be useful to go ahead and show that difference. So let's just do that real quick. So I'm going to do 5 cluster config. I'm going to create another cluster. And I'm just going to do a Cilium install on that one. Just regular Cilium install, no kubeproxy replacement. And then we can take a look at like how that actually compares, and we'll see what we're talking about here. Starting the control plane, installing storage class.
Whenever you refer to a previous episode, sometimes in my head, I imagine like the Dragon Ball Z. It's like, last time on eCHO.
That's right. Last time. Exactly. All right. Let me do Cilium install. One of those extra flags, because this is just a straight Cilium install, unlike that other one, which was a fancy Cilium install.
This is just a down home country installation of Cilium.
That's right.
One thing I noticed that something I want to dive into a little bit more, maybe do a discussion on that at some point. I see that in the kubeproxy replacement, there's a section for like backend selection, which is random, which is the way that kubeproxy does it, right? It does a weighted randomization for whatever endpoint you're trying to go to, and obviously kubeproxy is trying to replicate that feature as much as possible. But it'd be interesting to see, what ability we have to like change that a bit, and also like control how backends might get selected, right? And kind of explore different options for that.
That would be fun. I think that would be a good one. There's also some capability inside of Cilium to actually create to do chaos testing or chaos injection stuff, which would be fun to kind of also dig into in that space.
Oh yeah, for sure. Chaos has always been near and dear to my heart. I'm sure you know.
Same. kubectl get pods -a. So now in this cluster on the right side, we have Cilium installed, but we are running the kubeproxy. So let's go ahead and do that same experiment that we did before. So I'm going to do kubectl get pods -n kube system -o grep worker. And that will give me this guy here, kubectl ti and kube system. Okay. And then we do Cilium status verbose. And we can see that this kubeproxy replacement flat chunk looks very different. So from on this left side, where we're actually doing kubeproxy replacement, we can see that kubeproxy replacement is set to strict, that the socket LB is enabled. Socket LB protocols are TCP and UDP. Socket LB is wherein we have the ability to shortcut traffic back and forth between at the application layer. So two pods communicating in the same node we're able to basically shortcut that traffic leveraging BPF. We have the device, which is obviously going to be there. We have the mode is source NAT. The backend selection is random. Session affinity is enabled. Graceful termination is enabled. NAT6446 is disabled, and XTCP acceleration is disabled. In this right side, where kubeproxy replacement is enabled, we have basically the same set. Graceful termination is still enabled, but everything else is disabled. And then underneath services is where we get into some detail about how things are written, right? We have cluster IP enabled, node port enabled, load balancer IP enabled, external IP is enabled, and host port enabled. These are the types of service that Kubernetes supports. And over here on the right side, where we're actually running with kubeproxy, only cluster IP is enabled. The rest are disabled. So that's some of the key differences. Now, other things that are kind of interesting about the difference here. If I do Cilium BPF LB list, I can see the implementation of services, of cluster IP services in here already defined. So like this is the actual service for the Kube API server internally, and this is the service for that net service that we defined. So over here, I'm going to go ahead and deploy the same thing so we can actually do a comparison here. Dash 57 per node. It'll get pods. Supposed to come up. Service list for that service with a name. So it'll get service see that's 1096.89.102.
Going to check your pod.
Oh, I see. I know. No, you know what's happened?
It's an
Actually
old
really
command.
subtle. No, you know what's going on?
Oh, you're in the wrong namespace?
I'm in the wrong kube config.
Ah, I didn't catch that. Oh, I see. You're using the kube config for the terminal on the right.
I think that's local. We're going to find out.
I mean, it certainly looks different.
Okay, so the IP address that we saw when we did kubectl get service was 1096.89.102. And there is 1096. Wait. This is kind worker, so I'm on the right node. Cilium eBPF LB list 1096.124.218. Oh, because that's why. Let's just do a split here. We'll do kubectl get svc 1096.124.218, and that's that guy there, right? So that is our currently routable setup. Over here, I'm going to do the thing. I've got to do kubectl config. We're about to learn something here, folks. I hope this will be interesting. So what I'm going to do is I'm going to do kubectl config view minify x kind cluster. What I've done here is I've actually just broken these out so that they're no longer a part of the same file. Now I have two different kube configs, one for kind cluster, one for kind. My two example clusters here. Okay. So I'm going to go ahead and move this guy back to. Actually, I'm going to leave this guy on kind cluster. This guy is also on.
He was on kind.
Oh.
Yeah, you want to move that one to kind.
All right, so let's do that. So export kube config, because your exported variables are only specific to the process for which they are exported. They're not global variables. So when I export a variable, that variable is limited to the bash process inside of this terminal window. It won't apply to this bash process or this bash process. Interesting stuff. Equals kind, then export big kind. This was already still kind cluster. So now, where were we? Okay, so now advanced kube config handling. Status.
That could be an entire job.
Okay. So on the left, we have our kubeproxy and Cilium cluster. On the right, we have our kubeproxy with Cilium as a kubeproxy replacement.
Wait, say that again?
So on this side, over here on my right side, this guy over here, where it says kind cluster, that is actually the one that is actually running with Cilium in
KPI replacement mode?
No, this is one with kubeproxy.
All right, that was my confusion. I thought you said the opposite last time.
I did, and I was wrong about that.
No.
So kubeproxy is running over here, and we're replacing kubeproxy over here. Okay.
Got it.
So we showed the difference between those things. There's one other thing I want to share real quick, which is what we were talking about last time. If I do a Docker exec into this node and worker bash, I do a Docker exec into this node, cluster worker bash. I do IP tables, save, myself, 98 rules, IP tables, save. Are you ready? Any guesses? Would you like to go
I'm
higher
gonna
or lower?
say 300.
300?
Yeah.
194. Not very many services.
I was gonna say 200. I was gonna say 200, and then I was like, no, that's too low. Son of a gun.
So in this case, right, we have all of this stuff. These 100 lines are, well, most of them, basically all of that. That's all the way that IP tables is implementing these services. In this is how kubeproxy is implementing the service abstraction in IP tables. And in Cilium, we don't have any of that noise, right? We don't have any of this kube service stuff. If I do IP table save, kube SVC, nada.
Nothing. Yep. Or even cube SEP. You won't see that either.
Yep. Let's see, kube. It's 30 rules that match it on the other side. Yeah. All right, so that is the difference with kubeproxy replacement and not kubeproxy replacement. But how to, and kind of, you know, in IP tables, if I wanted to understand how the service was being routed, I could still kind of, in a sort of, you know, crazy way, understand how this is happening. But I have to do a lot of work that I did in this most previous episode. So if you want to go look back and look at that, it will show you exactly how I was showing you how kubeproxy works and how you can determine how the decision was made and all of that stuff. And in Cilium, you've learned today how you can determine how Cilium is going to make that choice, right? So if you do Cilium, back into our pod, or into our Cilium agent, we do Cilium, eBPF, LB, list, right? Then we can see the decision that's going to be made, right? When anybody sends traffic to this port or to this cluster IP, we're going to make the decision from the healthy backends on that cluster IP where to send that traffic.
Man, that's way harder to read than IP tables.
Yeah, right.
Yeah.
Now, there's one other thing, actually. So let's do this. Let's do kubectl create, actually expose. You know what? I guess I could expose the service, huh? Let's see if we can do that. Yeah. Type port name goes net np. Kubectl get SVC. So now we have another type of service. We have a cluster IP, we have a node port. Node port type service is actually implemented in IP tables in a way that, like, basically we create that service on every node, so you can actually access that service via a node port. And I'm going to do the same thing that we did last time. We're going to actually compare this with a cluster that doesn't have this. But first, let's just show that it works. Right? So this is us doing kubeproxy replacement. This node port that I just defined should be reachable from outside the cluster at any node IP address. Let's try it out. So if I do kubectl get nodes -o wide, I'll be able to see the IP addresses of the nodes inside of this cluster. And right now by default, just like it is with Kubernetes, if I send this traffic to a node where the service doesn't exist, it will still just forward it over to some other node where the service exists. And that's a tunable, like that's something that can be changed by definition in the service, but by default, that's what happens. Let's try actually accessing our service. Node port 32451. And it looks like it's working. And we can see that we're balancing between the different pods on the back end. Okay. So it's actually doing the thing we expect. And so there's no kube proxy in place here. Node port still works. Yeah. One more thing to actually show real quick, because it's kind of in kube proxy. Or sorry, in replacing kube proxy. This is a port
32451, I think.
One, yeah. Up here on the node, I'm going to do ss minus ln, which is kind of the same as netstat minus ln. It's just using the ss tool, which is a replacement for netstat.
I need to get used to using that. I still use netstat.
You can see that it isn't actually defined as a listening port. So how is that happening?
That is interesting.
It's happening at eBPF.
It's happening in the kernel level.
F. And I believe that we're able to see that in LB list as well.
Should be. Yep, there it
so
is.
There's that implementation. Right, and look at the bind address. Right, this is the node's IP address bound on port 32451, balancing back to all of the pods in that that can be reached by that service. And we can see that it is a type node port.
Yeah, and so if you were to go to one of the other nodes, you would see its IP address and then 32451 as
Exactly. And there's a bound, and there's a bind for all addresses, the same bind.
Yeah, so it's really cool. Like, you know, when we get a network packet, we inspect it at the kernel level and then are able to see all this information, you know, pull that out and then make a decision based on, you know, something that we got immediately, right? We didn't have to do any extra steps or anything like that. We just know exactly what we're looking for and where we're going.
Yep. Yeah. Now, I think... Yeah, we can see, you know, the NAT that's happening. We can see there's a bunch of other stuff inside of the BPF side. Now, one thing I talked about last time, which I have not repeated this time, but I think is worth understanding, is that the Cilium commands, there's like two different classes here, right? Like one class is this whole piece here where you can actually see the maps, you can see the node, you can see services. There's a bunch of other information here that you can actually see about how Cilium itself is configured or running at like runtime. And then the BPF commands are kind of represent sort of a different set of tools that allow you to understand how Cilium has configured BPF in relation to your configuration stuff.
And I think that's important to point out because, you know, when Cilium programs the BPF, you know, all the BPF code, it continues to be programmed in that state, regardless of the Cilium agent existing. So, and that's why they're kind of different, right? There's a Cilium agent configuration and then the BPF configuration. If the Cilium agent goes down, you'll still have routing because the BPF is already encoded, or, you know, the kernel already knows what to do with all the BPF logic that we've implemented. So it's really a very cool feature of Cilium. Sorry, I didn't mean to jump in.
No, you're right. I dig it. Cool. This is the contract table effectively that we see for everything interacting. We can see like security IDs. We can see how many bytes. We can see how many. We can see a bunch of information about what's happening in relation to traffic that's moving. that's the global table. And then you can also look by endpoint identifier. So if you do Cilium endpoint list, so this is one of our pods this is net1 kind worker. And our Cilium endpoint ID up here at the top of the column, it'll tell you which one is which. So the endpoint is this first one, and the identity is the second one. Identity can be related to the service, but this is unique to the endpoint. So if I go ahead and do a CT list and then the endpoint ID, it didn't work. It's this. Yeah, another. What do you install? Oh, I have Hubble's already in here. Let's take a look at Hubble.
You install the Cilium and you get the Hubble for free.
So here's the Hubble traffic moving back and forth between the cluster. If I go ahead and just focus on the default namespace, I can see any traffic coming to host. It finally shows up. There we go. There we got a hit, a couple other hits.
I love that it's color coded as well. That makes it so much easier to read.
Now, the interesting thing about one thing that's interesting about Hubble, usually with Hubble, you would be able to see all of the traffic, regardless of what node it landed on. When you use Hubble inside of the Cilium agent, you're only looking at the data or the events related to what is known about by that node, not by all of the nodes. If you were to do export Hubble server equals, actually, let's see, kubectl get svc-n kube system. Oh, Cilium Hubble enable. So let's go ahead and turn on Hubble and Hubble relay. And then when I turn that on, I'll actually be able to configure Hubble on the node that I'm on to actually let me see to see all the events, not just the ones on this local node. It's unfortunate. Like, I think, I can only see LinkedIn user, whereas like if somebody chats to me in the YouTube channel, I can see that it's Bojanch. But if you're a LinkedIn user, I can't really see who you are. But I do appreciate the questions. Waiting for Hubble to be installed. Okay, so now if I do kubectl get svc-n kube system, see our Hubble relay here. And now if I go ahead and just check back in, export Hubble server equals, and then the service IP. Port 80. Yes. You can see that we're talking to 3 nodes now, right? If I unset that variable, I can see I'm not able. It's not giving me the same output. But if I go ahead and set that again, I'm seeing all of the events. Now, if I do Hubble observe default, and I go ahead and do my curl again, I should be able to only see hits. I should see hits every time. And we can even see from this Hubble Observe, like, stuff that's happening, right? So in this case, remember I was talking about how the service, like, if you land on a service, if you land on a service where the traffic needs to get sent over to another node. Can you hear me?
Yeah, I can hear you.
Okay, good.
Yeah.
So, like, see this bit here? Right, this is traffic coming in from world to the default net2 kind cluster, and it's being sent to the overlay. Because it's actually terminated, it's picked a healthy backend that's on another node. And so it literally ships this to the overlay so that it can be sent to that other node. And then you'll see it come into the endpoint, to endpoint. Pretty neat. Anyway.
Yeah, I mean, this is super fascinating. I do really love this. Man, this is. Sorry, I was geeking out for a second. eBPF is just so cool.
Yeah, it is really neat. All right, so that I think that's probably a pretty reasonable place to stop for the day. We've gone through and we've kind of explored how node ports worked. We've talked about how kubeproxy replacement works. We've talked about a lot of different things. We've geeked out about all the stuff. I'm going to go ahead and delete my kind clusters.
Yep, we have a question from Dariush. Can you explain again about Hubble seeing traffic on a node versus the entire traffic? So cluster-wide traffic versus node traffic, right?
Yeah, let's talk about that real quick. Hold on, I'm deleting something so the stream is a little junky because I've created too many kind clusters.
Oh yeah. If you're I'll go ahead and run through this really quickly.
Go for it.
If you're looking at Hubble, right, you're using the Hubble CLI on the Cilium agent, that Hubble is only using the Hubble relay, local to that Cilium agent, right? So Cilium agent has a Hubble relay built into it that sends that information out as like metric data that Hubble can pull in. And so the local CLI, if you're running in like the Hubble agent or the Cilium agent pod, is only looking at that local relay. However, if you're using a Hubble CLI from your workstation, you're accessing every Cilium agent and then getting all of the information from all of them, so you're able to see all of that data, right? So it's a matter of scope.
Exactly. Yeah. It's basically that the way Hubble Relay works. To your exact point, like Hubble Relay makes a connection to each Cilium agent and aggregates all of that data into a ring buffer. So when you're doing Hubble Observe against the relay, you're seeing an aggregate of all events. When you're doing Hubble Observe against the local host, you're only seeing those events that host sees, just like Nick was explaining. Pretty neat. You can go to YouTube. Just if you scroll up a little bit in the Slack, in the comment channel here, you'll be able to see there's a playlist, and that playlist will show you the latest.
Yeah.
You can also.
When I was distracted earlier, I was trying to get the link for the episode that we're on, just to put it in the chat.
Ooh. It's in the notes actually. So if you wanted to,
we should have. I just went there.
I'm gonna go ahead and put that back in the brand here. So boink. All right. So I hope this was helpful. I hope it was educational. I enjoyed the heck out of hanging out with you, of course. Happy Friday, my friend.
Happy Friday as well. Happy Friday to everyone who joined us. I hope that you had a lot of fun and didn't feel stupid.
You're not stupid.
You're not. Absolutely not. No, this is a lot of fun. Thank you again for having me. Always a pleasure.
Yeah. Enjoy the heck out of your weekend, and we'll see you all next time. Bye.
Bye.
Go back to my brand here, and bye.